Hello, everybody. Thanks so much for coming along to, well, I guess this is a room, albeit a virtual room, and I'm beaming to you all over the world. So thank you for being part of this sort of online conference that was never designed to be online, but now we are. We're sort of, I want to say a big thank you to all the people behind the scenes that are sort of making this work as seamlessly as possible. And I hope for you as attendees that this experience has been still educational and enjoyable. I suspect many of you are perhaps enjoying or not enjoying forced lockdown in your homes. So I hope you're safe, you're well, and your family well. And I also hope you're keeping your distance and washing your hands. Feels like we have to say that all the time. Wash your hands. It's new information for some people. We're actually here not to talk about anything to do with uh, viruses or lockdown. We're actually well, we might talk about lock-in, which is a bit of a different thing, but we're actually here to talk about serverless computing in general. And I've got some sort of specific things to talk about, some sort of confusion that I still have. When I first wrote this talk, would have been about 4 or 5 years ago. I was very confused by serverless. Now I'm slightly less confused, but there are still puzzles that I have in my head, and I wanted to share that with you today. I actually previously written a couple of books on microservices. So I wrote the book Building Microservices back in 2014. It's published in early 2015. And I think I just happened to be the first person to write a book on microservices, which is good timing. I've actually also just published a brand new book, came out at the end of last year, called Monolith to Microservices. This is a book all about system decomposition. I actually just did a 2-day class as part of NDC Copenhagen. Maybe some of my workshop attendees are joining me here, in which case this plain wall behind me would be all too familiar. As well as writing books, I also run my own training, advisory, and consultancy firm. I sort of do a lot of work remote, which I did before this as well. So if there's anything you think I can do to help you and your organization in your microservices journey, I'm very easy to find on the internet, but I'll place a link to that at the end. Throughout the talk today, I would really encourage you to ask questions. So go over to Slido, use the hashtag NDCCPH. You can find my session in there. If you pop the questions in there, when I come to the end of the talk, I've got about sort of 15 minutes free to sort of go through and answer those questions. There's a little bit of a lag between me speaking and you getting to hear that, and then you being able to ask questions. So if you ask questions as they come up, then towards the end of the class, I'll have a lot of questions that I can go through. I'll also spend a bit of time on Slack afterwards, answering as many questions as I'm able to, although I have to actually go off and get some shopping for some of the local infirms. So I'm doing my bit. So in case you're not entirely clear who I am, this is me. This is my picture. It's my profile picture. Despite how I might look, I am actually quite an old person now in the grand scheme of computing. I've been doing computing sort of professionally, I suppose, which means I think I was getting paid to be a computer programmer for about 24 years now. So although I might to some look youthful and fresh-faced, I do in fact feel a lot more haggard. Just to give you some background of how old that makes me, I still remember when the internet came on a semi-floppy disk through the post, when you used to have dial-up broadband. Some people still have dial-up broadband. I live in the country and it feels like I've got dial-up broadband, but I only too well remember the thrill of getting my first 14.4K modem. I remember when Facebook was the Facebook, and I still insist on calling it the Facebook, and I still don't understand what Snapchat is, but thankfully it seems I don't have to worry about that anymore because it's now all TikTok. And as far as I can work out, TikTok is just dog videos, which again is something that I can deal with. I'm not too much of a fuddy-duddy. I have been keeping to an extent on the cutting edge. I was sort of lucky enough to be involved, sort of working with AWS from the very earliest days. I actually sort of helped create the first ever training courses for AWS back in, I suppose it would have been 2008 sort of time frame. And so I've been working with cloud in sort of public cloud technologies for a long time. I've also got a background in sort of infrastructure automation. So I've always considered myself sort of half an operations person and half a developer. And certainly I've been very, very interested in the capabilities of sort of various different public cloud providers, of which, AWS very much was the sort of set the scene really, and is still the market leader. But there have been some things coming up recently in this space which have led to me being a little bit more confused. And this is, things I'm not quite sure what's going on. And I've been trying to make a sense of this sort of more confusing and emerging landscape. And specifically that confusion stems from this topic of serverless, right? So serverless What does it mean? What does it mean to you? What makes it different? And maybe I'm going to try and sort of maybe cut through a little bit of the hype around what serverless is, be a bit more specific with what it means as well, because I think the term gets misused. But also, I'm sort of keenly aware that I need to be all on board with serverless, because I am, if nothing else, something of a hype merchant. And as you can see, here's microservices, my own particular buzzword on which that I spend a lot of my time. We can see here from the Gartner hype cycle, microservices is surfing high. I always find this particular chart from Gartner quite odd, because there's microservices at the peak of inflated expectations, which is right where I'd like to be. And there we've got SOA in the trough of disillusionment. I find this confusing because microservices are just a type of SOA, which says to me that the people that create the Gartner hype cycle don't understand that. But here we see in the technology trigger department is serverless. And although this graph is actually a couple of years old, it has been surprising that serverless technology, or serverless as a concept, I don't think has made as many inroads, certainly into enterprise development, as I might hope. But nonetheless, there is another hype term. I've got to jump on board that bandwagon. I'm going to attempt to actually surf both bandwagons at once, both microservices and serverless, and we'll see how that goes. And of course, when you hear the term serverless, that immediately, makes us scoff a little bit, because it sounds like marketing buzzwords, right? When the reality is that we know that there are computers there. So what does that even mean? Is it just as simple as saying, well, serverless is just another way of saying other people's computers? And maybe there's something to that. The term actually comes from an article, and this is by a chap called Ken Fromm, writing for RW Labs. Now, I don't know. I've done some research quite a bit, and I've yet to find an earlier reference to the term than this one by Ken. And so in this article, he's really talking about what he was seeing as the future of cloud development and really just general software development. And so the phrase that jumped out at me is, when he's talking about what serverless means to him, is, the term serverless doesn't mean that servers are no longer involved. It simply means that developers no longer have to think that much about them. Computing resources get used as services without having to manage around physical capacities or limits. It's sort of interesting. He doesn't really talk about public versus private cloud, although I think, as we might explore a bit later on, in general, the good serverless offerings are primarily in the realm of public cloud. There are some areas where that gap's been closed for private on-premise experiences, but primarily, I think the good serverless stuff is on the public cloud providers. Now, for many people, serverless is synonymous with cloud functions, with Lambda functions, what we have sort of these product offerings under what's known as FaaS, function as a service. So serverless for many just means FaaS. The sort of first widespread FaaS style offering, although I think you could easily look at other alternative products in this space that predate this, but the big the first product that got a lot of excitement in this space was AWS Lambda, which was launched in 2014. And that's sort of interesting, right? Because Lambda was launched in 2014, 2 years after Ken came up with the term serverless. So when he was thinking about serverless, he wasn't thinking about function as a service. So there is this thing here, which is those two terms aren't necessarily as synonymous as we might think. Serverless actually really speaks to a whole category of cloud products that we can make use of that further abstracts us away from really the detail behind it. Fundamentally, it's about us working with a platform that allows us to get on with our jobs. We don't have to worry about the underlying machines, right? And this is kind of in many ways, the concept of serverless is very much contextual. It's about your position in this stack of abstractions. If you are somebody making use of a serverless product, as far as you're concerned, there are no machines underneath. It is very much about being in the eye of the beholder there. But if you're somebody managing this platform, this is very much, there are machines. And I think this is also creating some interesting conversations when you look at things like the use of FaaS on premise, for example, because what I find confusing in those environments is really you want to deliver a product, a feature set to your developers where they don't have to worry about machines. But often they still have to worry about machines because they're running on a shared Kubernetes cluster and they're only allowed a certain number of pods, which creates this really interesting disconnect. And this concept of perception is kind of quite important, right? Serverless, if nothing else, is about giving us abstractions. It's about hiding the detail. But those of you in the engine room might still have to look after all of these machines. I don't think this is partly why I think there's going to be a challenge in delivering quality serverless products on premise, because I still think though the kind of abstractions we create for developers working on the private cloud are quite leaky abstractions in many cases. Mike Roberts wrote an article called Serverless Architectures a couple of years ago now, actually 2016, there we go, 4 years ago. And so he wrote this over at Martin Fowler's site, but he wrote sort of explaining what serverless is. And again, Mike takes a broader look at all of the stuff underneath serverless, talking about what it means to be serverless. He was trying to get a bit more distinct in terms of what it means. But he's very looking much more broadly. He's looking at things like function as service, backend as service, messaging products, the whole lot. And although Mike specializes mostly working in the AWS ecosystem, the stuff in here is very much applicable across Azure and across Google Cloud, although Google Cloud has a much smaller offering in this space. So Mike's own definitions of what makes something serverless is that there's no management of server hosts or server processes. When you're engaging with a service product, you're not saying, I want this many machines. I'm not saying I want 5 of these machines in this data center. None of that. You're not worried about that. You're not worried about operating systems or patches that have got to be applied. That is all dealt with for you by the service provider. The serverless product itself has got to auto scale and auto provision based on your usage. So as your use of it increases, the underlying serverless platform has to automatically work out what you need and provide that to you. That means sort of scaling up and scaling down. The third idea here is that we are charged based on what we actually use. So, and this is the idea of precise usage. If you think about a traditional managed virtual machine, the standard cost model, say for Azure virtual machines or AWS EC2 instances, is that you get a machine and you pay for it by the hour. Now that's still amazing compared to buying a machine for life, right? But you're still paying for the full hour. If I only run one request on that machine, I've still paid for the full hour. Whereas with things like the FaaS platforms, if I only have one request, I only pay for that request. The other thing here is this is where things get a bit kind of interesting. You still do need some ability sometimes to specify how much or how powerful you want something to be. And so you do, with the Lambda functions, for example, you have the ability to specify, I would like more memory for a function because it's maybe more going to be a more intensive workload. But the way that Mike talks about this is your performance capabilities, you're defining it in terms of something other than a number of machines. If you look at DynamoDB or Cosmos DB, for example, which are sort of backends, sort of serverless backends that are provided on AWS and Azure, you use the equivalent of allocation units. You pay for a set of units that allow you to run queries, for example, against your databases, but you're not saying, I need more machines to handle that load. It's like you're buying extra capacity on that ultimately shared resource. And the final item here is that we have implicit high availability of these resources, right? So these service offerings, we don't have to do anything. They are just going to automatically handle failures for us. So if a node dies, that should be pretty much transparent to us. We shouldn't even have to worry about that, or we shouldn't have to care about that. So again, there's this idea again here of abstraction. We're giving developers higher order abstractions to work with quite powerful cloud-based functionality. We're hiding details in terms of having to manage those workloads. We're not having to worry about the operational infrastructure costs here. We're also getting implicit high availability given to us by the underlying platform. And so, yes, as we mentioned earlier, function as a service here has become to being almost what people think of as serverless. So AWS Lambda, Google Cloud Functions, Azure Cloud Functions. Actually, really been impressed with. I'm not a bigger user of Azure, but I've been quite impressed with Azure Cloud Functions in terms of offering quite a wide breadth of different programming languages. And that's an important thing with things like with all of these abstractions. When you give somebody a higher level abstraction to work with, you also end up placing constraints upon them. When you run a function, a cloud function on any of the three big cloud platforms, you are often constrained in, well, you will be constrained somewhat in your language choices. So it's not just a case of saying, well, we support Node. Like I think Google only supports Node, Python, and Go at the moment, and Java. It only support 4 languages. It's not just that; they've also got to support your specific runtime of that language, because they actually manage the runtime for you as well. Again, this is where Azure's got a bit of a head start. It supports lots of different programming language. I think you can even theoretically run Windows bat files on, as cloud functions. I mean, you shouldn't, but I think you can. But there's also other things in this space that fit. I mean, we've got backend as a service type offerings like DynamoDB, like Cosmos DB. There are storage products like S3 on AWS. You've also got things like messaging based products. Think about the Azure Event Hub. You're not provisioning a messaging cluster, you're just sending messages around. On AWS, you've got Kinesis, you've got SQS, you've got SNS, and these are all serverless messaging based products. And so the idea that serverless is quite narrowly just functions, it's not. All of those product offerings, if you think about it, you just throw messages in, you just put data in, you get charged based on the data going in, you get charged based on your usage. The high availability is handled for you. You're not having to do any of manage any of the detail. They're all also serverless. Going all the way back to the roots of AWS, the first public products that AWS made available were SQS, which was their simple queue product, and S3, their blob store service. Both of, S3 especially is an amazing product. Both of those were launched in 2006, and they are both totally serverless. It's sort of interesting to think that that serverless concept was with us early on, but that's not what we caught light, right? What caught light was really infrastructure as a service. I don't think we were ready for that level of abstraction to deal with, right? Now, when it comes to something like FaaS, if you haven't used a function as a service platform right now, I mean, that's the first thing you should do this weekend. Go grab the serverless framework, play around with cloud functions on Azure or Lambda functions on AWS. They are really, really kind of, it's almost like it's close to the perfect developer abstraction as I think we've found for working with sort of cloud-based code execution. So the way it works, you work on your laptop, you create a piece of code, and then you basically upload that code to the FaaS platform, and to apply that change. So you say, okay, well, what you basically do is say, here's some code, and when this thing happens, and that could be a message being put into, say, one of the messaging products, it could be a HTTP request coming in, could even be like a file arriving in, say, a blob store service, then launch my function. And so then what happens is when those things happen, when those requests come in, the FaaS platform behind the scenes automatically spins up a machine to handle that workload. So the request comes in, it will launch a function to handle your request. So you're not having to worry about configuring a host. You just say, here's my node function, run it when this happens, or here's my Python function. When these requests come in, launch my function and pass in the request into that function. You only pay for what's running. So, if I've only got 4 instances running, I'm only going to be paying for those 4 instances. As more requests come in, the underlying FaaS platform is going to spin up more instances for you. And so it can scale up and scale up. There are limits around how far it will scale. Some of those limits are soft limits. You can put those limits in place yourself. But you get this sort of automatic ability to scale up without having to really think about it. Now, that can create challenges for hybrid type architectures. We'll talk about that a bit later on. And also, they will spin down. This is also quite useful. When there are no requests coming in, no events being served by your service, you will not be paying for anything, right? Your service, your sort of functions will sort of vanish. Now, it's interesting, I sort of touched on this idea that I see function as a service as being like almost the perfect developer-friendly abstraction for running workloads on the cloud. And it's taken the crown for me from the previous incumbent, which was Heroku. So I think Heroku nailed a really great developer-friendly experience for working with cloud-based resources. And I think it's, in many ways, is still the sort of gold standard for a developer-friendly PaaS offering, platform as a service offering. And you can see how that's played out in so many products subsequently copied that sort of the command line and some of the concepts in Heroku. Cloud Foundry got completely rebuilt really to mimic the Heroku interface, and developers love working with Cloud Foundry, even though operations people aren't always as so friendly. But on the face of it, something like Heroku doesn't qualify as being serverless. With Heroku, you spin up dynamos, you spin up web workers, you're still managing kind of really abstractions over virtualized machines. And so although it's awesome, it's probably also not serverless. We're still at a slightly lower level of abstraction. By the way, I still think you could do a lot worse than actually making use of Heroku, even though, if unfortunately, since it got bought by Salesforce, they haven't done a great job really of continuing to have to grow and have the impact that it once did. So these ideas of sort of layered infrastructure and sort of high level abstractions are kind of this is almost part of our never ending quest as developers and as IT people. We're always looking to create higher and higher level abstractions to help us get more stuff done. If you think about what happened, we used to just have physical infrastructure. We used to have to buy a machine and rack it up, right? And then we started virtualizing that infrastructure. Think about virtualization in terms of, your standard vSphere, VMware type 2 virtualization running on your premise, making better use of the physical resources you had. And then, of course, we had infrastructure as a service, which is really what AWS nailed so well early on, creating infrastructural virtualized primitives that run in the cloud that nonetheless, although they're a virtual resource, they feel very much like the physical resource, and we can engage with them in the right level. And then we started building sort of higher level abstractions on top of that. Think about the fully managed database services, for example, from Azure and AWS. So an AWS RDS, for example, which is their relational database service, I'm saying I want a database, it's this big. Behind the scenes, AWS are making use of their own virtualized primitives to kind of create that service offering to you. But we're sort of dealing with it at one level of remove. We're not worried about the operating system, but we are worried about the database version and those sorts of things. Also, we've got container orchestration as a service. Think about, the various, Amazon, so Azure ACI. You're thinking about the AKS, the sort of managed Kubernetes services, where we're now sort of another step removed from the underlying virtual machine. We're now thinking of container workloads running on those clusters. And then we've got serverless. So we've got the various different messaging products in this space, the backends as a service like Cosmos DB or Athena or DynamoDB, and the sort of, the various other types of offerings that you've got from the cloud providers. Weirdly, although Google's got a really narrow product set in general, it has a really deep product set when it comes to databases. It's kind of one of their expertise areas. There's a lot of stuff that fits that serverless model, pay as you use. And of course, FaaS, right? Function as a service. And then we've potentially got the sort of that even more high level abstraction, which is maybe what we would consider the platform as a service. So the traditional view of a platform as a service, which is we do everything for you. And the problem with that is if you didn't like something it did, it was quite hard to break out of the constraints of that system. The thing that serverless does well, I think, is gives us higher level primitives that we can assemble together to give us the platform as services choice. So I think it's a really neat balancing act between giving us a high level of abstraction that allows us to get lots of work done while pushing away a lot of the underlying operational work, but still being flexible enough that if we didn't like one of those components, we could take it out and replace it with something else. And so as you go up this sort of level of abstraction, you've got less overhead from a point of view of managing infrastructure, but you're also having to give up control, right? You're having to trust the provider of the platform that they're going to do things for you. And you may not have access to all the low level abilities to control things. When you launch a function on Azure or AWS, the only control you have is how much memory you're giving something. And that's sort of it. As you come down this stack, you get more low level access and much greater control. I actually think for a large number of organizations, I think most of the teams I work with, although they think they want more control, they actually don't. They're actually be quite happy being at this sort of higher level of abstraction. But there's a bit of a fear in giving up control. And some of that fear is based into things like sort of vendor lock-in, which we'll talk about briefly in a minute. Even Kelsey Hightower, who's been an amazing champion for Kubernetes. Kubernetes fundamentally is not a developer-friendly platform. It just isn't, right? It's very good at managing container workloads, but you see everybody that ends up using Kubernetes and tries to create platforms internally ends up using layers on top. They buy into something like OpenShift or Cloud Foundry, which can now run workloads on top of K8 clusters, and so developers don't actually like working with Kubernetes. It's too complicated, really, for what it is. It's fantastic at sort of densely packing developer workloads. And Kelsey, who's been a great champion for Kubernetes, is totally on board with this idea of serverless being the future. I think that I may have got him on Twitter during his moment of epiphany, right? Which is, I understand what the serverless fuss is about. When you have a great idea, the last thing you want to do is set up infrastructure, right? This is the dream, right? We've got a problem, we go solve the problem. We don't have to worry about the work being done behind the scenes. We offload that to somebody else. And I think with serverless, we're just getting a bit better. It's almost like we're getting our collective eye in as to what makes for a developer-friendly product, service, or offering. Now, coming back to Ken's article from the beginning, the phrase serverless doesn't mean that servers are no longer involved. It simply means that our developers, this is the important thing, our developers no longer have to think that much about them. This is fundamentally about creating developer-friendly abstractions that make sense to them and their world. And I think people that are deep into their Kubernetes clusters often can lose sight of the fact that although they understand Kubernetes very, very well, an awful lot of people don't have to, to be honest with you, either. Another sort of kind of take on serverless I quite like this one from Bilgin, which is, functions is a programming model, and serverless overall is a billing model in a way, right? So you can sort of think about serverless shifting the way we think about billing. Functions as a subset of serverless is almost like a programming model. We're thinking differently now about how we structure our programs to take advantage of this new kind of deployment paradigm. I sort of talked a lot about this idea that serverless is going to take work away from you. And there's a phrase that I keep coming back to in my head, and that's the phrase of undifferentiated heavy lifting. And this was a term that Amazon used a lot when talking about the mindset behind why they created AWS. So they would create these sort of small polyskill teams. And the idea was a small polyskill team should own the delivery end to end of a product offering, something that would actually reach the customer. It's still how Amazon to this day operates. It's also partly, I think, how AWS continues to outperform the other cloud providers in terms of being able to deliver new products. So the idea was we own the whole thing end to end. It means that we don't have to coordinate with other people. We have a lot more autonomy and we can go fast. But they realized that those teams were suffering, that they had a huge overhead in terms of having to manage the infrastructural part of themselves. So they were actually having to buy machines and rack them up and cable them up. And so Amazon said, well, and they defined all that work was almost like busy work as undifferentiated heavy lifting. It was difficult work that our teams were having to do that doesn't actually help us achieve our goal of shipping products. It's like what our ability to configure infrastructure as a team doesn't help us in the market, right? Our ability to recommend great product to you, if you've based on what you've ever bought, that differentiates ourselves from the rest of our competitors. But we're doing lots of work that we should just be doing. So the idea was, can we just get rid of that? Can we outsource that? And so sort of AWS, internally inside Amazon, is a set of services that those polyskill teams can use to offload work that doesn't differentiate what they're doing from anybody else. So rather than dealing at this level, you're dealing at a different level of abstraction, so you can focus more time and effort on your stuff. I think all that's happening now is that we're seeing more and more of the work we do in the infrastructural space as being undifferentiated. Your ability to run a Kubernetes cluster is almost certainly not going to be a competitive advantage to you, especially if you could have somebody else run that Kubernetes cluster for you better than you could yourself. Like if you want to run Kubernetes, and I don't think everyone should, but if you do, great. Why run it yourself? Just go use a managed provider, right? Pay them to do it. They'll be better at it than you will. That frees up your time, energy, and money to work on the things that your customers want. Your customers probably don't want a Kubernetes cluster. Your customers probably want cool, great quality software that helps them with their problems, unless you're a company that runs Kubernetes clusters, in which case you go for your life. This is a kind of continual thing for us, though, as developers. We've been creating higher and higher level abstractions. That's what we do. We're almost hardwired for it. Brian Mack is one of the signatories of the Agile Manifesto. He said once to me, developers, we turn caffeine into abstractions. That's what we do, right? We convert out, we take that. That's what we do. You give enough caffeine, you'll get lots more abstractions. We're obsessed by it. You know, when think about that mantra of dry, don't repeat yourself, we beat into ourselves. In code, we're always creating abstractions to allow us to work at a high level remove. You know, we started off with machine code, working at a very, very low level on the underlying infrastructure, underlying chipsets of our machines. And then we realized, you know, hang on, there's a better way. So we created assembly code, right? Assembly code allowing us to work at a high level abstraction. And of course, when people started coding in assembly, the machine code people go, oh, that'll never catch on. You need to be right at the low level. You know, it was much better here. You got all the control. And the assembly people were like, yeah, whatever, granddad. And they got on with their day and they started getting more stuff done. And then we realized, you know what, we can do better at than assembly code. That's when we started creating sort of high order application programming program languages, you know, which sit on top of assembly underneath. Now, very rarely do you ever actually have to worry now about the actual runtime target you're operating on. Your operating system means less and less. The underlying chips, the machines mean less and less. You know, that shift that sort of maybe first for me at least happened when I moved from being a Fortran and C programmer over to being a Java developer was significant. The abstraction of the JVM allowed me to say, well, I don't actually have to worry about running on I was writing software that ran on Sonos, HPUX, DEC Ultras, didn't have any DEC Ultras as that, SGI machines, and Windows machines. I didn't have to care about the differences anymore between those. I could just work at that one level of abstraction. Got a lot more done. I was a lot more productive. And so abstractions, when they work well, can be amazing for us. But there are some things to consider in this serverless space. So while I was exploring this, I started looking into more case studies around serverless, people that have done serverless and what they'd found. And I found some interesting things around aspects like resiliency. So many years ago, I was working at an investment bank. That investment bank no longer exists because of the thing called the global financial crisis. And if you want to know more about that, I can recommend watching the film The Big Short, although the original book that this is based on is excellent. It's by Martin Lewis. And we were basically calculating these things called collateralized debt obligations, which were a type of financial instrument. And we basically were running these calculations on a grid computing system called Data Synapse. Sort of a bit of an old-fashioned style of architecture now, but actually, it's the kind of thing you'd use a Kubernetes or a Hadoop cluster for nowadays. Probably Mesos would be a better fit. We had this sort of cluster we'd run these jobs on. And so we had all these machines running these workers, and then we had all these sort of upstream resources that we'd pull information from. Like we'd pull the ability to pull risk data out or market data, which would be one of the inputs into our calculations. And primarily what we're doing here is looking at the various, how risky were these different trades that we were doing. Of course, we realized in hindsight, we had very bad ideas how risky these things were. And then ultimately, we do these calculations and we'd stick them into some kind of database. And that was all kind of nice and good. And what we were realizing was, well, we'd actually used up all the machines that had been allotted to us. We were looking for ways of actually scaling out the grid. And the software we were using actually allowed these pricing agents to run as screensavers. The idea that people went for lunch and their laptops, their desktop machines they would have been then, weren't being used. And then suddenly you'd have a lot more machines able to run this pricing. And so at lunchtime, we've realized, well, if we could use people's screensavers, we could get a lot more work done. We also found a whole disaster recovery center that we had that was sort of north of London. The idea being if there was ever an issue in London, they'd all decamp to this other site to carry on trading. And this system was like, these machines were like not being used, right? They were sitting there. They actually had to be switched on, but they weren't being used. So we thought, great. So we rolled out our screensaver to this center, this DR center. And like overnight, our pricing grid scaled from a few machines to hundreds of machines. I think we went from 25 to 250 in one day. And it was amazing. And things started going fast and fast. And then some odd things started happening. Like everything outside of the grid basically vanished. And what had happened was that as we scaled up our workload, we overwhelmed everything that wasn't itself also scalable. So we kind of bombarded the upstream services with requests and we wiped out our database. And what had happened was we had no way to sort of balance or throttle the requests we were making. We were basically this is basically a classic case of mismatched resources, right? It's like having a load of water going into a small pipe, right? It doesn't always work very well. Now, if we think about it in computing, we have lots of things that we take for granted that we use to actually throttle. A classic example of that would be something like a good old-fashioned database connection pool. So I've got a node running here. It's going to talk to a database. We have a certain number of requests that we will allow through that database for our connection pool. So when you want to make a database query, you actually get a request. You get a connection from the connection pool that allows you to then make queries. So as requests are coming in that require our access of our database, these requests go to the connection pool. They go and grab that connection and make the query. If there's more requests than we have connections available to them, they'll have to block and wait until that connection is available to them. And the idea here is that allows us to basically throttle the amount of load that goes through our database. And if, in the worst case, we can actually time out the upstream requests, which causes us to basically shed that load. That reduces back pressure. And so this is actually a very common thing that we do that you probably do already without realizing it. These connection pools allow you to sort of balance how many requests can go to these downstream resources. And that works though, because ultimately your connection pool is managing a connection pool for multiple requests, and that it has some sense of state as well. So between requests, it has some shared state to know how many requests have I got going on, how long are those requests taking. You can also do things like circuit breakers as well. Now, of course, we don't have anything like that when it comes to something like functions. With Lambda, with Cloud Functions and Azure, when a request comes in, we launch an instance of a function. That instance of a function is stateless. It cannot share any state. Therefore, it has no concept of something like a shared connection pool. What that basically means is we have no throttling mechanism that we can have built into our function, because our function can only throttle on a function-based basis. So that's no good to us. We still could have 500 functions running. That could result in 500 requests going to the database. Whereas a similar set of workload running on, say, a normal application instance, we might actually be able to throttle that quite easily, because multiple requests would be handled by a single process. And that basically causes issues, right? Now, I've wondered, is this just a theoretical issue? Is it going to be affecting other people? I asked around. I said, what about this situation? And a lot of the people from Azure and AWS said, well, it's fine. You just use a different database. Just use a database like DynamoDB or Cosmos, which is designed to just scale up as you need, which is great. But what about people that can't just go all in on these serverless frameworks, or can't go all in on these serverless products? What about hybrid situations? What about situations where you don't want to migrate your entire architecture to these new things straight away? I saw a really interesting talk by a team called Bustle. So this is Steve Faulkner who did a talk. I think it was NDC Oslo. It might have been 2018, I think it was. And he talked about their experiences of moving over to serverless, making use of Lambdas. They were on AWS, and this exact problem happened to them. They were using React as their underlying database. We can have a separate conversation about whether or not you should use React as a database, but they had exactly this problem. They were getting overwhelmed by the number of function invocations, and that would actually completely kind of wipe out their underlying React instances. So they actually ended up having to bound how many functions would invoke just because of another downstream issue. They also had to do some quite low level stuff in their networking stacks on the actual machines that were running their React instances to actually shed connections earlier to stop those services being overwhelmed downstream. So this problem with, like, you've got part of your infrastructure that can really scale up quite drastically, it can overwhelm those things that don't have those same scaling characteristics. And so that's something that's got to be considered when you have these sort of hybrid and hybrid-based applications. Now, look, part of this, some of you are thinking, well, look, how much of this is you just worrying about nothing? Do you really have thousands and thousands of machines that are going to spin up? Are you really worried about issues that aren't going to affect most people? And the reality is, maybe for a lot of you don't care about thousands of nodes, and probably most of you don't. But you do probably about tens or hundreds. And the reality is, if we're offloading our sort of needs and desires onto an underlying computing platform that claims to be able to scale up, and it can, we still have to deal with the implications of what that means when other parts of our systems can't handle that. I actually think what we're starting to see even in multiple situations now, organizations that are looking to sort of hybridize their sort of architectures on the cloud, you're starting to have to look at building these throttling mechanisms in place yourself just to protect yourself against these things. I think for some people, things like app meshes and stuff like that could make sense. Having something that sits between your functions and external services that has the ability to sort of limit those connections. So maybe service meshes might be the answer here in the longer term. Although I think it's early days for when we think about how service meshes and functions work together. Security is another kind of interesting one, right? There's a lot of concerns around security because people started to realize quite quickly that things like FaaS were just running on containers, and to an extent, I think for some of it was well intentioned and some of it was correct, but there's also a lot of confusion around the concept of security and containers specifically. So when you run your function, it is being run inside a container by the underlying runtime. Now, of course, in the early days of Docker, Docker was primarily based to do isolation of resources. It wasn't designed as being a completely secure enclave. And so there were situations where you could get from one container to another. The underlying Docker runtimes themselves weren't really built for thinking about untrusted code. That has improved significantly. Like all of the container runtimes are doing a lot better here. But we sort of had this mantra that friends don't let friends run untrusted code in containers, because the level of isolation provided via a container certainly was much poorer than it was for a normal virtual machine. As I say, that has improved drastically. But what people started getting worried about was, well, okay, well, if I'm running my container workload on FaaS, what if another malicious party can somehow break out of their container and access my container? The reality is this is much less of a concern than I think people realize. Because firstly, if your function isn't running, it's sort of not there, ish. And in any case, you're not running a full container, you're running a function that runs inside a locked down runtime, which itself is running inside a container engine that is also quite locked down with lots of constraints around it. And actually, in some cases, are actually fairly isolated. I'm not sure if this is the case, but certainly one case, certainly for a period of time, I believe that Azure Cloud Functions, for example, were actually running in full vSphere containers that have isolated kernels, giving you additional isolation. So actually, from a security standpoint, this is actually pretty good, right? Your function's only running if it's being used. If it's not being used, it's not sitting around, so it can't be attacked. It's very hard for a malicious party to break out of their sandbox anyway. I don't know of any currently known exploits that allow you to do this. And even if you could, it would likely be an indiscriminate attack anyway, because the chance of you running on the same machine as the person you're trying to reach is pretty minimal. And again, this is some of the beauties of sort of offloading work. If you think about a modern application stack, right, we've got the underlying hardware, we've got the operating system that sits on top of it, then we've got the hypervisor, because you're probably virtualizing your infrastructure. On top of that, you've got your virtual machine operating system, and on top of that, we are running Docker or some other container engine. On top of that, we've got your container operating system, and on top of that, you've actually got your operating system. And I've simplified this. I haven't put a Kubernetes cluster in here, which would further complicate this diagram. But every single layer of that stack is going to need looking after, management, observation, and patching. I wonder how many of you are confident, if you're running, say, in a private cloud, that every single layer in that system is being patched and as those patches are kept up to date. Like, I know that all the public cloud vendors rolled out those Intel patches for Spectre and Meltdown within 7 days. I suspect that some of you are still running in companies that are running on hardware that haven't been patched for those exploits, because we don't think about patching the hardware. And as our stacks get more and more complicated, there are more and more moving parts to worry about. Now, if we're, say, running our infrastructure in terms of managed virtual machines, sort of you working at the level of cloud infrastructure as a service, we can offload a lot of that responsibility to the underlying cloud vendors. So the hypervisors, the operating systems, all that stuff is being handled by somebody else. If we're basically making use of, say, a cloud container platform, we can push even more of those concerns to the underlying provider. They're now running not only the virtual machines, they're looking after patching the Kubernetes clusters for you as well. And you're just sort of dealing with the level of your container. And that can focus your energy and your attention just on your container, your application. With functions, it's even better. Even more of our work is pushed away. And now we can really just focus on the stuff that we care about the most, which is just your code. And now all you've got to do is to stay up to date with patching your code when new vulnerabilities are discovered in the libraries that you use. And the great thing there is we have awesome products like Snyk out there that can really help us in terms of making these things better. Snyk will just, it will look at your repos, it will look at the dependencies that you have on third-party products. It will send you a pull request when it identifies that you've got a dependency on something which has got a critical vulnerability in it. It will say, this thing has a critical vulnerability. Here is a pull request. If you accept this pull request, we'll update the version you're using to one that has the patch in it, right? You can put that in your builds. You can fail builds if you're relying on libraries that are out of date. Snyk is awesome. You should go use it. So it's quite cheap for what it does, but that's great then, because now I've got, Microsoft are managing most of the stack for me now. I'm just worried about my application. I can get more work done. I can spend more of my time building features that make a difference to my customers, and that I'm not worried about, does my ability to roll out patches really distinguish me and my company from anything else? Is that a competitive advantage? Should it be something I worry about? Or should I just have somebody else manage that stuff for me who can do a much better job than I can? And I think that's really the secret to all of this. I mean, fundamentally, I'm just going to skip forward a little bit. I've talked so far mostly about this idea of serverless and the serverless offerings being something that you can only experience on a public cloud offering. There are initiatives out there to actually create some serverless type offerings on premise. Most of this work is being done looking into building things on top of Kubernetes clusters. So probably the most widely used example of, say, the function as a service on platform is FaaS. A number of companies are using this nowadays, although there's been other competitors out there. You've got Fastnetes and Fission and OpenWhisk and OpenLambda. There'll probably be something else coming out shortly. Although I think now, if you want something for today, take a look at FaaS. We also have Knative coming soon. So Knative is something that's really was originally being more of a community-driven thing. So Knative is Google saying, here's how we should do that sort of function as a service type workflows on top of a Kubernetes platform. Unfortunately, Knative has now been taken really out of the community development, and it's now really being driven entirely by Google. And so early on, a lot of work was being done by people like Microsoft and Red Hat to support Knative. It's going to be interesting to see if that continues now that Google has said, no, this is ours, we're taking it. They've actually taken that out of the CNCF, which is a bit disappointing. I think it was interesting. I saw a lot of people stalled in going ahead with using FaaS on premise because they were waiting for Knative. I think a lot of people have gone back to FaaS now. Google don't have a track record of getting this stuff. They're quite good at talking about what will happen, and it can often lag a long time until these things are ready. It took a very long time for Kubernetes to get to 1.0. It took a very long time for Istio to get to 1.0. And even when they did, they made fundamental large-scale changes to how their systems worked after the fact. I think we could fully expect to see the same sorts of things happening with Knative as well. And that might be exacerbated given the much less involvement from other parties that Knative is going to have. But we'll see what happens. For those of us on the public cloud, we don't have to worry about any of this mess. We just go use the cool serverless offerings that are out there. So fundamentally, right, for me, when I think about what serverless is, it's just all about abstractions. This is all abstractions all the way down. Coming back to the machine code, assembly code, application code type abstractions we think about. For me, serverless is just a continuation of that. We don't think about chipsets. We abstract ourselves away. Now we extract ourselves away from operating systems, and now we may be even into a place where we can sort of abstract ourselves away from things like containers and runtimes. If you want to know more about sort of serverless, I've got a whole sort of 2.5-hour presentation all about serverless fundamentals for microservices. I'm actually writing all this stuff up at the moment for a second edition of my Building Microservices book, but you can find a lot more information about the work I do. You can find a video of lots of other talks that I've done out there, including ones on sort of security in the context of microservices over on my website, as well as details about how you can get your own copy of Monitor Microservices. But thank you so much for your time and your attention. We've got, I think, 10 minutes or so for questions. So I'm just going to switch over to Slido and see if we've got any questions coming in. I have lost Slido. I'm going to shut Slido down, which I think is extremely unprofessional. So let me just get into NDC Copenhagen. Right, and I'm going to put these questions up on the screen so everyone can see them, just in case any of you said anything insulting about me. But I suppose this also means if I skip the hard questions, that's going to be pretty obvious to you all. So we've got a couple of questions here. So thanks so much. So while I'm answering these questions, if you want to ask more questions, pop over to Slido. Just use the hashtag NDCCPH. So here's a comment here from Azure Functions. You can put a setting on Azure Function to limit the number of requests you're allowed to receive. That I would imagine you're doing that actually at the API gateway, and so that does depend on. So it'd be interesting if that's at the API gateway level, or if you're doing that at the more generic evented level. If you think about it conceptually, these cloud functions just get invoked based on some event. For many people, that's just a call coming in via the API, via HTTP or something like that. In which case, that both on AWS Azure, so both on AWS and on Azure, that means routed via an API gateway. You can definitely do request throttling at that API gateway level, but there are other sources of requests. And if I have to think about every potential input to that and throttling that, it feels like I'd rather do that at the function level rather than at the upstream ingest level, if that kind of makes sense. Like I drop a file in S3 that can trigger a function. How do I throttle that? But that has got a lot better, to be fair. Early on, these controls were not available to us. I think early on, certainly with AWS, you couldn't even you had a hard limit of how many function invocations you had, but you couldn't even specify a maximum number of function invocations on a per function basis, which was a real problem. That has now been fixed. There's another question here, is when do you think that cross-FaaS communication will appear? I send a cloud event in a standardized manner from any FaaS to another FaaS. I mean, you can do that now. There's nothing to stop you doing this whatsoever. The means, I can write, so from one function running on Azure, I could hit a HTTP endpoint that actually triggers a function on AWS. Not a problem at all. So for me, I think you can do that in many different ways. Always thing to be aware of if you're bridging across cloud platforms. The issue there really is about, well, latency and bandwidth, right? This is always the thing about hybrid or multi-cloud solutions. When you send any information out of one public cloud provider into another public cloud provider, you're being charged on the way out and you're being charged on the way in. And then you have to wait for how long for that call to happen. Of course, you're effectively going over the public internet at that point. So if I send a HTTP request from my Azure function to my AWS function, I get charged on the way out. I then have to wait for the request to be received in AWS. AWS charges me on the way in. It doesn't work. It sends the request back and back in again. Bandwidth, often when it comes to cloud pricing, is the secret killer. It sneaks up on you. And people who are building multi-cloud solutions will start to get bitten quite early with those, because it tends to be the ingress and egress at the sort of the perimeter of the public cloud services tends to be where those bandwidth costs are the highest. And so as a result, most people who are doing multi-cloud solutions, they will often be quite selective in what cross-cloud communication they do. And I see this stuff happening more often in terms of region to region within a single provider, rather than say from one cloud provider to another. So there's a question here, do I think that GCP and AWS will support .NET Core for FaaS? I would be very surprised if AWS doesn't. With GCP, who knows? I mean, I have no inside track. AWS actually is doing a pretty good job of rolling out new language support. It's behind Azure, I think. But it is catching up. I'd be surprised it's not even in Hang on a minute. I'm looking this up. I thought this was in beta. I'm looking this up, right? I'm speaking as, yeah, I mean, you can do it already with the custom runtime. So you can now, right? I'm showing you a link. Here we go. This is from 2019. So there's half the presses. Here we go. We have a custom runtime support. So this actually allows you to run things. Look, there we go. It's great. So it's all there. So you can Google as well as I can. So that's great. Now GCP, who knows? I mean, for something that's so conceptually simple as cloud functions, it's amazing to me that they've still got such poor support for runtimes. like really, really limited. I think Java support for cloud functions on Google is still in beta, which I think is really disappointing. So I have like zero expectations that that's happening anytime soon. But Google are for some, onto themselves when it comes to these sorts of things. And I am still bewildered by some aspects of their cloud strategy. But then, you know what? I am just one mere independent consultant, and maybe I'm missing the bigger picture. But yeah, that's unfortunate because Google Cloud do have some excellent stuff. Their databases, I think, the database offerings they've got are amazing. I think the quality of their managed virtual machines are really first rate. I just think they do suffer from a lack of breadth of offerings in some space, and yeah, the lack of language support on those on their function runtimes, I do think is disappointing. Just going to refresh this and see if we've got any other questions that have come in. I don't seem to have. Oh, that was silly of me. You're getting to see all my mistakes in first hand. I guess I just wanted to quickly see, we have got a few people that have dialed into the Zoom chat. So maybe just wanted to quickly ask if anyone on the Zoom chat wanted to ask me a question. You can ask via Zoom chat, or you can also just use your voices on your microphones if you have anything you want to ask me. No? Okay. Well, thank you so much for your time. I am available on the internet if you want to carry on asking me questions. Oh, here's one. Do you think that Azure has managed a better development experience for their FaaS compared to AWS, who started earlier? There is one specific area that I think Azure has done a great job for a developer experience, and that's with durable functions. It's an obvious thing that you'd want a lot of functions to work together, maybe as part of an orchestrated workflow, for example. AWS has step functions, which are basically, let's write loads of JSON to coordinate how these things talk to each other, which from a developer point of view is rubbish. Whereas cloud functions sort of embrace the idea of continuations and hook those into the reactive extensions to allow you from a code point of view to basically do things like an async await on another function invocation. So that's really, really cool. At that level, Azure's doing better. At another level, they're both doing terribly. Conceptually, function as a service is such a simple thing. It's such a simple concept. But if you go through all the getting started guides or trying to use the console, it's an horrendous experience. There are companies like Zeet, for example, who are really showing what a good quality developer experience should be. So there's actually still a bit more too steep a learning curve, I think, into getting on board with these platforms. Once you're in, it's a lovely place to be. This is actually why for function runtimes, I do suggest that people take a look at the serverless framework, which is stupidly named. So the serverless framework, here we go. They got serverless.com, clever them. It's an open source product for working with various different serverless product offerings, and it gives you a really nice command line for working with different function invocations. To an extent, it gives you an abstractions over different underlying providers. I think it actually works with open FaaS and stuff like that. So what I suggest, if people want to give a go of using, they want to try out a cloud function for the first time, they've got a couple of hours, I would say download the serverless framework, point it at your cloud platform of choice, and you'll get started a lot quicker. There's definitely work that could be done to improve the experience on all of those platforms. Oh, the other area that Azure's done really well is around debugging. Like their local and remote debugging story around cloud functions is way better than Amazon. But again, I think that speaks to a mindset. AWS don't like to get involved in what happens inside the box, whereas Microsoft are quite happy doing that. For durable functions to work, you actually need support inside the SDKs running on the cloud platforms. Likewise, you need the same if you want to do local and remote debugging of the cloud functions. AWS have never really wanted to go there, so I think it might just be a bit of a mindset thing. That might limit how deep they can get involved in that areas. The debug stories around Lambda functions is not great. I mean, they use the sort of effective emulation to do that, which is not as good as the real thing. Anyway, I have rabbited on enough. Just double check some other questions. We've got a couple of minutes left. Okay, so I have, how do I answer? So I've done. Yeah, so I like serverless framework. I've already said that. Terraform, I would not put these two things in the same bucket, right? Terraform, I would not use Terraform in the same place I'd use a serverless framework. Terraform's great, but for Terraform is something that I would use for sort of managing more, sort of managing my widespread cloud resources. I think it's really, really good there. Another example of that would be something like Pulumi. I like Pulumi a lot, so definitely take a look at Pulumi. But I almost see the role of things like Pulumi and Terraform as replacing Puppet and Chef for managing cloud-based infrastructure. It's not necessarily something that I would focus and point a developer at. I think a developer, honestly, most developers are quite happy with using something like what the service framework gives you. But if you're interested in Terraform, do go take a look at Pulumi. But for me, I wouldn't use them. So like I would use the service framework just for maybe your command line, your developer command line tools for working with your cloud functions. I might use Pulumi or Terraform to set up the wider cloud infrastructure that my teams use. Again, personal preference. If you want to know a lot more about Terraform, Pulumi, and how they set into sort of this whole ecosystem, an old colleague of mine, Keith Morris, has written a book called Infrastructure as Code. Yeah, the second edition of Infrastructure as Code is actually available over at the O'Reilly site. So if you want to know more about this whole space and how these different tools fit in, then do head over to this website and you can find out how to get early access and learn all the stuff you want to know. We are at time. Thank you so much for the great questions. I'll pop over to Slack and I'll be in Slack for the next sort of 10 minutes or so, answering any other questions you have. But if you miss me on Slack, feel free to ask me questions on the internet. And there is loads and loads of information about me and other work I do. If you want help with consulting, services, anything else, you can find me on the internet. So thanks very much for your time.